So now we are going to see about the next topic, which is the Earth's interior. What is inside the Earth? That we are going to see in this Earth's interior. Okay. So I told earlier the hot molten material. You can see about the volcanic eruptions. Okay. Hot molten lavas or molten materials will be coming out of that volcanoes. No, that explains that inside the Earth there is so much of temperature and so much of pressure is there. That is the evidence. Those hot molten materials are evidence of the temperature present inside the Earth. Okay. So what is the Earth's interior? We have taken a cross-sectional view of the Earth's interior. This is the Earth's interior in a cross-section way. Okay. So it consists of an inner core, an outer core, and there are mantle, upper mantle and the lower mantle, which is the molten mantle, and at the topmost it is the crust. This is the cross-sectional view. Okay. So what is present in this inner core? Inner core, the innermost layer, and it is the more densest is the core. Okay, more denser area is this inner core, and it is mainly made up of iron and nickel. Okay, so this core we can say it as knife because iron and nickel. So core is made up of iron and nickel, so it is the knife. Okay, so what happens next? The core consists of, the core is of two types, inner and outer core. Inner core is more denser and outer core is not that much denser, or it is not that much in a solid part. Okay, that is about the core. And about the mantle, upper mantle and lower mantle, which is known as the molten material. This upper mantle is in solid form and the lower mantle is not in that much solid form, it is in the molten state. Okay, so what does this mantle consist of? Mantle is known as sima because mantle consists of magnesium and silicon. Magnesium and silicon. So they will call the mantle as sima. Okay. Next we are going to the topmost layer, which is the crust. So this topmost layer, crust, consists of silica and aluminium. Okay. Because of this only it is known as the Cl. Okay. Silica and aluminium. So this three you should remember, very important, because that UPSC may ask this in a MCQ type or match the following, or they can give it in a statement wise. Okay, so the innermost core consists of knife, nickel and ferrous. Okay, nickel as ferrous, and the mantle consists of silica and magnesium, and the crust consists of silica and aluminium. So knife, it is knife, sima and Cl. How you can remember is, inside a knife has been kept. Above that you have kept your SIM card. Okay, above that it is Cl, okay, which is a real thing. So knife, SIM card, real. So knife, sima, Cl. Like that order you should remember. This is very important. The Earth's interior is very important. So in a crux, I will say again, there are three parts inside Earth's interior. One is core, mantle and crust. Okay, core is of two types, inner, outer, and mantle is of two types. Upper and lower mantle, and crust is of one type, only crust is there. Okay, so inner core, which is more denser and it is rocky in form. This outer core is not that much solid. With regarding the upper mantle, it is solid, but your lower mantle is molten in state, and crust is the outermost and it is also more denser in form. Okay, so that is about your inner Earth's interior. Okay, so one question arises here when we are talking about the crust, which is the outermost layer of the Earth, crust. There are two types of crust. One is the oceanic crust and other one is the continental crust. Okay, crust formed inside the continent or the landmass is known as the continental crust, and the crust which has been formed inside the sea is known as the oceanic crust. So which one is more denser? That question arises. So the answer is the oceanic crust is more denser. Why I am saying this question is, once UPSC asked this question. Okay, why the UPSC asked about the reason why this oceanic crust is more denser than your continental crust. Okay, in another question, UPSC asked that which is denser, either your continental or your oceanic crust. The answer is your oceanic crust is denser. We will see why. Why this oceanic crust is more denser? Because this oceanic crust is consists of mafic minerals like very rich in iron and magnesium, due to which the density is more higher. Okay, the oceanic crust is made up of mafic minerals. On the other hand, your continental crust is made up of felsic minerals, which are rich in alkalis. So only it is very low in density. So that is the reason why your oceanic crust is more denser than your continental crust. And also, generally speaking, your oceanic crust melts to a higher fraction than your continental crust. This is an added fact here. Okay, so that is about your Earth's interior. When you are studying about the Earth's interior and you have known about this formation layer like core, mantle and crust, you should also know about the types of rocks. So next topic we are going to is the types of rocks. So now we are going to see about the types of rocks. So how a rock is made up of? A rock is made up of a collection of minerals. Collection of minerals is known as the rock. Okay. So basically saying in general, rocks are of three types. Okay. One is the igneous rocks, sedimentary rocks, and metamorphic rocks. I'll write it down. First type is the igneous one. Igneous rocks, sedimentary rocks, and metamorphic rocks. Okay. So what are these igneous rocks? These igneous rocks are also known as the parental rock or the primary rocks, because these rocks are made up of, I told you, the magma, the hot molten magma which erupts from inside the earth, and it comes out and spreads as lava. Okay, that lava will form as a crust, and that will develop into these igneous rocks. Okay, magma in its upward movement cools and turns into a solid form called the igneous rocks. Okay, the process of cooling and solidification, this process, okay, see, the magma is coming from beneath the earth, and it is coming in the surface of the earth, and it cools down as lava. Okay, this cooling down or the solidification, the process known as solidification, this solidification can happen in two areas. This solidification can happen inside the earth while it is coming, when the magma is coming itself, the solidification can happen, or the solidification can happen on the surface of the earth when once it has reached the surface. In two places it can happen. Based on that, these igneous rocks are divided into two. One is intrusive and other one is the extrusive. Okay, so when the solidification process happened inside the earth, that is known as intrusive, and once the solidification, if the solidification is happening in the outer part of the earth, it is known as extrusive. Okay, so there are two types of igneous rocks. So these igneous rocks are the parent rock or the primary rock, because they are made up of this magma and lava. This magma comes out, becomes lava, and that lava develops into this igneous rocks. So that are the primary rocks or the parental rock. Now we are going to the sedimentary rocks. What are the sediment? You know, sediments are formed of layers. Okay, so what happened is, these igneous rocks, these parental rocks, they day by day they got weathering. Weathering means what to say? A rock is there and high winds are blowing, and these igneous rocks, they are formed into fragments. They will destroyed into fragments, and they got collected as sediments, and they will these fragments will move from one place to another, and they form as sediments in some places, and a rock is formed. That is known as the sedimentary rocks. Okay, so these sedimentary rocks are nothing new. These sedimentary rocks are formed from igneous rocks only. When these igneous rocks weather, they form into fragments, and those fragments got collected into a sediments and formed as a rock known as your sedimentary rocks. Okay, so your sedimentary rocks formed by successive deposition of sediments. Sediments may be debris eroded from the previously existing igneous rocks. So your sedimentary rocks are formed from the previously existing igneous rocks. Okay, these rocks have some type of fossils between their stratas. Why fossils are formed? Because they have been I can say there are some 10 igneous rocks. Okay, some 10 igneous rocks will produce millions of fragments. Okay, these millions of fragments will get collected, they will form sediments, and they will form into a sedimentary rock. Okay, so this sedimentary rock will form a collection of rocks. It is not made up of a single rock. Collection from all the rocks gets sedimented and forms into a rock. So they will be having more number of strata, and you can easily differentiate between a sedimentary rock and igneous rock. If you see igneous rock, it will be blunt or it will be straight. When you see a sedimentary rock, you can see more number of layers, and you can minutely observe there will be more number of strata or fossils between each layer, which clearly says that this rock has been formed from all the fragments and they have developed into a sediment. Okay, that is about the sediment rocks. So what about your metamorphic rocks? Metamorphic rocks are nothing but metamorphic rock. What happens is, when these both igneous and sedimentary rocks, they undergo a transformation. How they can go transformation? Change of form. That is known as metamorphic, change of forms. These rocks are formed under the influence of heat or pressure on sedimentary or igneous rocks. Okay, like your change of color, change of hardness, or the change of the brittleness. Like these changes are happening to a rock, that is known as the change of forms. Due to this, new rock has been born, that is known as the metamorphic rock. Okay, so metamorphic rock, again there are two types, like thermal metamorphism and dynamic metamorphism. When this change of form is happening via heat, that is known as thermal metamorphism, and the change of form when it is happening via pressure, it is known as dynamic metamorphism. Okay. So the process, the metamorphic rock undergoes a process, I told now. That process is known as recrystallization. A process called recrystallization takes place here. What is this recrystallization? Let us say that a rock, an existing rock, either igneous or sediment rock is here. Okay, this rock is present here, and now a new lava comes from beneath the new molten material come beneath the earth, and it gets solidified with the already existing rock. Okay, now this rock form will be changed, and that will give rise to the metamorphic rock. So that process is known as recrystallization. So what is the process of solidification that we have learned in igneous rocks? When the molten materials are coming out, piercing out from the earth, they are solidified and formed as igneous rocks. The recrystallization process happens with the metamorphic rocks. So they will give this process name, and they can ask which rocks has been formed. That also one type. Okay. So before that, the sedimentary rocks, okay, the sedimentary rocks, we have discussed how the sedimentary rocks has been formed. This igneous rocks or the parent rock, that will be weathered, okay, that will be weathered, and they will be formed as fragments, and they will be transported. These fragments will be transported. In what way they will be transported? They can transport it in any ways, like they will be transported in an airway, or they can transport it via lake, or insects can even take those transportation, they can involve in those transportation. Depending on that also, the sedimentary rocks has been divided into many types like aeolian, lacustrine. Lacustrine means when the transportation takes place via lake. Aeolian means if the process takes place by the air. Like some types are there, and also the sediment rocks has been differentiated by the formation, by the type of formation. Also there are some different types like mechanically formed sedimentary rocks, organically formed sedimentary rocks, and chemically formed sedimentary rocks. Okay, and also if you see all the huge folded mountains like Himalayas or the Mount Andes, these all mountains has been formed by the process of the sedimentation only. The huge fold mountains of this world has been formed because of this sedimentary rocks only. Okay, so about metamorphic rocks also we have seen. Another one main thing about here is about these types of rocks is UPSC has been consistently focusing on the examples of this type. Okay, examples for these rocks UPSC has been consistently asking. I have seen many questions regarding that, and also in the state government exams also I have seen questions of this type. Examples they will ask, they will give some examples of the rocks, and they will ask to identify which type of rock it is. Okay, so examples, just note it down. Okay, first I will say with respect to igneous rocks, examples are granite, gabbro, pegmatite and basalt. These are the examples for igneous rocks. Next we will go to sedimentary rocks. Examples are sandstone, limestone, dolomite and shale. These are the examples for sedimentary rocks. Finally, about metamorphic rocks, examples are marble, diamond and slate. These are the examples for metamorphic rocks. Okay, so these are the examples of all these three rocks. So again we will see in the crux what are the rocks. I'll just recap once again. Igneous rocks are known as the parent rock because it is formed of the molten material. When the molten material solidifies into lava, igneous rocks has been formed. So they are known as the parent rock or the primary rock. That is igneous rocks. Sedimentary rocks, when these igneous rocks breaks down or it gets weathered, they will be transported in many forms, like we have seen lacustrine form or aeolian form. They will be transported and they will be collected. The fragments will be collected and they will be forming into a sediments, and a rock is formed, that is known as the sedimentary rocks. And finally metamorphic rocks, when the change of form, when these igneous rocks or your sedimentary rocks, they change in form, like the change of color, change of hardness, anything change happens, then a new rock has been formed, that is known as a metamorphic rock. What is the process involved? Recrystallization is the process involved of this metamorphic rocks. And with respect to igneous rocks, what is the process? That is the process of solidification. So this is about the types of rocks. Next we will see about the earthquake, how this earthquake is happening and what is the types of earthquakes. Okay, so we have seen about the types of rocks. Now we will see about this rock cycle. Okay, so what is this rock cycle? This rock cycle is a process by which the old rocks turns into a new rock. As you all know, this is a cycle. Okay, so we will get in detail how the cycle is working out. We all know igneous rocks. We will start from here, igneous rocks. So igneous rock is a parent rock. Okay, so what happens is this igneous rocks undergoes a process known as weathering and erosion, and it will form into sediment. So what is this weathering and erosion? You all know igneous rocks is there, which is a primary rock which is formed out of magma from inside the beneath the earth. Okay, so igneous rocks is there, so there are high weathering happens there. So in detail about this weathering and erosion, we'll study in the landforms. How this weathering is affecting the landforms we'll study. But now understand that if you keep a rock and if you leave it for 100 years, then that rock will be eroded. When wind will be blowing, rain will be falling. So because of this, erosion happens. So what happens? Erosion means while weathering, these rocks will be broken down into small fragments or sediments, I'll say in a better way. Okay, so these igneous rocks undergoes a process known as weathering and erosion, and it will be break down into smaller sediments or fragments. So these fragments, these sediments will undergo another process known as lithification, and this will turn out into the second rock, which is sedimentary rock. Okay, so what is lithification? Lithification nothing but a process in which all the fragments under pressure colludes and forms into another rock. That is known as lithification. By this lithification process, a new rock known as the sedimentary rock has been formed. As you all know, sedimentary rock will have layer structure and it will be having more number of strata in between them. That is sedimentary rock. From here what happens is the sedimentary rock will undergo a process known as metamorphism, and a new rock known as metamorphic rock is formed. So what is this process metamorphism? Metamorphism is nothing but change of form. In very simple terms, this is change of forms. When a rock's color changes, or the hardness of the rock changes, or the brittle nature of the rock changes, when this change of forms are happening, then a new rock known as metamorphic rock has been formed. This metamorphic rock will undergo melting. How this melting happens? You all know. During the seafloor splitting, I told, the old rocks will get separated when the new magma comes out. Okay, this new magma comes out, and these old rocks will expand, and they will go into a fault. Okay, when this go into these older rocks, when falling into a fault or ocean ridges, this what happens is friction is produced. More number of friction is produced, and more heat is produced. Because of that heat, these rocks will burn, and it will form into a magma. Magma is nothing but a liquid form. Okay, so this metamorphic rocks undergo melting because of huge number of friction, and magma, liquid form is formed. And this liquid form, magma, will undergo another process known as solidification, and again igneous rocks are formed. This magma, what is solidification? Solidification nothing but like your freezing. Freezing is a state where your liquid will turn into a solid. Same thing happens with the process of solidification also. So from magma, igneous rocks are again formed. So this cycle will be going on from igneous rocks to sedimentary rocks to metamorphic rock, again to igneous rocks. So the very important thing with rock cycle is understand these processes: weathering and erosion, lithification, metamorphism, melting, and solidification. Where these process happens, that is very important. So since we have seen about the Earth's interior, now we also need to understand about the earthquake, how this earthquake has been formed. We already know that some intense hot molten is burning inside the earth. So can you imagine how much temperature it will be there and how much pressure will be there? So the hot molten material always wants to come up. Okay, so it will be pushing from the downward, from the beneath of the earth, it will be pushing with so much of energy. Okay, but what to say, as the overlying rock strata that we have studied about in detail, about the interior rock, we have studied now crust, mantle, core, mantle, and the crust. This formation is there. This rock strata will push down, and the energy and the molten material wants to come up, and this will pull up. So this process will happening inside the earth. Every day it will be happening. Okay. So what happens is, so they can't escape those energy or those molten material. They can't escape. Okay, so they will be continuously pressing. Okay, at some point of time, what happens is it overcomes the friction. It overcomes the friction, and the energy will be released. So since the energy, they will find some way to escape. Okay, sometimes the friction is overcome and energy has been released, and so the rock strata will undergo some deformation. Okay, so this energy will escape through those deformation and comes out. That is the entire crux of this earthquake. Okay, now we'll see what actually happens is, let us see, this is the surface. Imagine this is the surface. Okay, so if you take an earthquake, this will be the focus or the center point. Okay, they also say this as hypocenter. Okay, a point near surface, it is known as epicenter. This is the surface. Okay, you all know this is the surface. So what happens is, from this focus hypocenter, this energy wants to come up. Okay, so some waves will be generated. Okay, some waves will be generated. So always these waves will come and attack this epicenter. So there will be huge destruction in the epicenter only. This is the earthquake I have taken. Earthquake, there is two parts. One is the focus hypocenter, also known as hypocenter, and a point near surface is known as the epicenter. Okay, so what happens is, always there will be great destruction in epicenter only, not in the hypocenter. Okay, as you have seen in tsunami also, you can see if tsunami is happening in the mid of the sea, nothing will happen, no damage will be there. Okay, damages will be caused in the shore only. Okay, if tsunami is happening, if you go into the middle of the sea, nothing will be happening. In the shore, so much of destruction. Same wise only. In the middle, nothing will happen. But in the shore or in the surface, more destruction will be happening. In the epicenter, destruction will be happening. This also UPSC has been focused and asked question about this hypocenter and epicenter, where the destruction is more. UPSC has been asked this question. Okay, so that is important. So with regard to earthquake, there are two waves of earthquake. One is known as the body waves. Another one known as surface waves. So what are those two waves we will study? Body waves is the release of energy at the focus, which is the hypocenter. Release of energy at the focus moves in all direction. Okay, moves in all direction, traveling through the body of that earthquake. That's why it is known as the body waves. On the other hand, what is surface waves? Surface waves are body waves. These body waves which are generated in the focus, they will come into contact with the surface and they will form a new wave. Okay, that is known as surface waves. So the body waves are the primary or the initial waves which the earthquake starts. Okay, these body waves will go and touch the surface, and because of that a new wave is again formed, that is known as a surface wave. Okay, so 2 points to be very clear here. While earthquake is happening, at the focus of the earthquake or at the center of the earthquake, also known as hypocenter, there is no much damage. Okay, damage is always caused in the epicenter, which is near to the surface. That is one point. Next point, there are two types of waves when an earthquake is created. One is body wave, another one is surface wave. Body wave is the primary wave which is formed near the focus. When this focus energy is released, a wave is created. That wave, it is the primary or the initial wave. That wave is known as the primary wave or the body wave. Okay, that wave will come into contact with the surface and a new set of wave is formed, that is known as a surface wave. Okay, now we'll go into detail. Okay, this body waves are classified into two types that we'll see. So these body waves are again classified into two types, known as the P waves and S waves. P waves are primary waves and S waves are secondary waves. Okay, this is nothing but you have studied in your mechanical. Okay, types of mechanical waves, transverse waves and longitudinal waves. Now, like same only, the same concept is applied here also. It is also wave, that is also wave. Okay, so it is relatable. So body waves, P waves and S waves. So what happens with this P waves is, these are primary waves as I told you earlier, similar to sound waves. Okay, travels easily through gas, liquid and solid. Okay, these P waves, they travel easily through all the material like gas, liquid and solid. They are the first to reach the surface. They stretch and squeeze. One important difference with P waves and S waves is P waves travel parallel. Okay, P waves travel parallel to the direction of wave, and your S waves or secondary waves are perpendicular to the wave direction. Okay, since your P waves are parallel to if the wave direction is in this way, the P waves will be generated parallel to those directions. So there will be stretch and squeeze only. There will be stretch and squeeze formed. On the other hand, your S waves, okay, your S waves will be perpendicular to the direction of the wave. If the direction of wave is in one side, then this secondary waves will form in the perpendicular direction of the wave. Okay, so what happens is, here what will be formed is crust and trough will be formed. Here stretch and squeeze will be formed, and here crust and trough will be formed. Same like your mechanical waves only. Okay, there also the same concept is there. So you can relate very easily, physics students especially. Okay. So the one important point is, as I told you earlier, this P waves can go through all your liquid, solid and gas. But your secondary waves can travel only through solid. They can travel only through solid materials. Okay, this question has been asked in many state government exams. Okay, like which wave can pass through solid materials only? P waves or S waves? S waves is the answer. Okay, S waves can travel only through solid materials. On the other hand, your primary waves can travel through gas, liquid and solid. Okay, this is about your primary and secondary waves. What are body waves? Don't forget, body waves are the primary waves which are generated. When the energy is released at the focus, a wave is formed known as the body wave. These are the primary and secondary waves. Okay. Also, I told surface waves cause more damages than your body waves. Okay, your body waves doesn't cause that much damage, but your surface wave cause that much of damage. Imagine tsunami. I have told an example. At the center of the sea, nothing happens, but in the surface or on the shore, damages happen. That is about your this earthquake. Okay. While dealing about earthquake, we will see another one small topic which is related to this, which is the movement of the Earth's surface. Okay. Movement of Earth's surface, there are only two movements. Okay, one is vertical and other one is horizontal. You all know what is vertical. Vertical is this movement. Okay, this is the vertical movement. So because of this vertical movement, uplift, what to say, a portion of the earth will be rising or falling down. This is the vertical movement. Okay, due to this, rise or fall will happen. What about horizontal? Horizontal movement of earth means like this. It will be pushing or pulling away. Because of this, folding and faulting will appear. Folding and faulting will appear. What is this faulting? Movement occurs along a rock and break the fault. That is faulting. Okay, a fault will happen. So don't confuse. There are two movements of Earth's surface. One is vertical and another is horizontal. Vertical is this type. So because of this, rise and fall will happen. Horizontal is pushing and pulling away. Because of that, folding and faulting will appear. Okay. So while the horizontal movement of the Earth, it will be compressed. The movement of the Earth will be compressed like this. So what will be formed is, two things will be formed. Two things are formed due to the compression or the horizontal movement of the Earth, syncline and anti-syncline. This portion during the folding, this lower portion is known as the syncline and this upper portion is known as the anticline. Okay, so that is the movement of the Earth, vertical and horizontal. During vertical, uplift and downlift happens, and during horizontal, compression and rarefaction happen. So we have seen this P waves can go through solid, liquid and gas, while your S waves can go only through solid. Okay, so how you can remember this is S, secondary, and solid, S. So these two are relatable. Okay, so P waves can go through all these three, but your S waves can go only through solid. You can ask me why? Because only the solid material will have the respective shear strength. Okay, once this S waves reach the surface, it will reach in a horizontal manner. Okay, so the surface, the liquid will not have the corresponding shear strength to support that or to pass through that. Okay, that is also the case with gas also. Okay, this liquid or the gas will not have the respective shear strength to support or pass the S waves through that. On the other hand, your solid will have the exact shear strength. So only your S waves can pass through the solid. On the other hand, it can't pass through the liquid and gas. And that's it about, I have finished this also. So that's about the Earth and the Universe module. We have completed, we have started from the solar system. I'll just say a recap of what we have studied. Okay, we have started from the solar system and we have studied of the planet and how this universe has been formed, and we have studied in detail about all the planets. Next we have seen about latitude and longitude. Latitudes and longitudes we have seen. Then rotation, revolution, about the movement of the Earth. Rotation causes day and night, and revolution causes the seasons. How seasons are formed also we have seen. We have seen solstice and equinox. And also we have seen about the time zone. While dealing longitude, I told how these time zones are calculated. We have seen about prime meridian. We have seen about ideal, international date line. And I told what happens when you are going to the east, one day is added, and when you go to west, one day is subtracted. That is the logic behind that. And also we have seen about eclipses. Also we have brushed the topic. And continental drift theory, seafloor spreading, plate tectonics. These three are relatable only, and I have dealt about that theory in detail, and I have also shown some evidences for that also. And finally, I have taught about Earth's interior. What are the Earth's interior, like core, mantle, and crust? That layer we have studied. And what is the knife? Don't forget that. This is very important. Core, the layer is like this: core, mantle, and crust, and it will be knife, sima, and seal. That is the layer. Don't forget that. Okay, that is about the Earth's interior, and we have seen about the types of rocks, three types of rocks: igneous, sedimentary, and metamorphic rocks. And also we have seen about the earthquake, two types of waves: body waves, surface waves, and we have seen P waves and S waves. That's also very important. And finally, we have seen about the Earth's movement also. With this, I am closing my first module, which is the Earth and the Universe. Okay, if you feel If you have any doubts regarding these sessions what I have taught, or if I have missed any topic, please feel free to leave in the comment section. And also we have done some experiment also regarding solstice and equinox also. I hope you are very thorough with that experiments. If you have any doubt regarding that experiment also, please mention in the comment section. We will do a separate video for that also if you need it in that case. Okay, so with that I am closing. Please subscribe to the channel and like this video and share with your friends. Thank you.